Air pollution is a global issue. A major pathway for air pollution exposure is via inhalation of fine particulate matter, or PM. Now, generally, regulatory bodies worldwide measure the PM bulk mass concentration to estimate the toxicity of air at a particular location. Now, this means if at a location the PM mass concentration is high, it's assumed that the air toxicity at that location would also be high. Now, the question is this assumption always true? For example, let's say you are at a beach and you know the salt concentration in the air at a beach would be high. Now, this salt can also elevate the PM mass at that location. Now, does this mean the air at a beach is more toxic than, let's say, the air next to a busy street with similar PM mass concentration? No, it does not. And it's difficult to answer this question because PM toxicity is a function of both its mass concentration as well as its chemical composition. So essentially, we require a more biologically relevant toxicity metric which can take into account both these factors. One promising toxicity metric is the oxidative potential, or OP, of ambient PM. OP is the ability of PM to induce oxidative stress, which is the underlying mechanism by which cells get damaged when we inhale air particles. So, for my research, I designed and developed a new real time OP measuring instrument, which directly measures the OP of ambient PM with a time resolution of 1 hour. This figure shows how the instrument actually looks like. So far, so in this instrument, we designed a new air sampler which directly collects PM into a liquid solution. And after every 1 hour of sampling, we send this to our analytical component where it measures the OP. So far, I have deployed this instrument in Champaign, Illinois, and in Delhi, India, to get a good spatial variation in the OP measurements. Based on the data collected so far, I can clearly say there is a non-linear relationship between PM mass concentration and toxicity, which clearly suggests that PM mass concentration is inadequate as a toxicity metric. Based on our findings, I propose using OP in future health exposure studies to get a better understanding of the relationship between PM exposure and adverse health risks in different geographical locations all over the world. Thank you.